Polarization. Electromagnetic waves are made up of electric and magnetic fields. When a light wave leaves its source, it is said to be polarized as it has oscillations in more than one direction or plane. When a filter or polarizer is placed in the path of light, all but one oscillation is blocked. Therefore, polarized light only has oscillations in one direction, the plane of the direction of energy transfer. Polarization by transmission. Light waves can be polarized using a polarizing filter. When the transmission axes align, half of the light passes through the first and second filters. Rotating the second filter decreases the amount of light transmitted, thus changing the light intensity. When the transmission axes are exactly 45 degrees from each other, the intensity will be half of what gets through the first filter. When the filters are at 90 degrees, no light will get through the second filter and the intensity will be zero. By reflection. Unpolarized light can be polarized partially or completely by reflection. The amount of polarization in the reflected beam depends on the angle of incidence. Reflected light is always horizontal plane polarized. Vibrations are parallel to reflecting surface. It only occurs off non-metallic surfaces. High degree of polarization leads to glare. By reflection. Waves hitting a surface where refraction is possible will partially reflect horizontally polarized light and refract vertically polarized light. Iceland spar is a crystalline form of calcite, and a special type of polarization occurs. The two refracted rays are polarized with perpendicular orientations to each other, double split. Uses of polarization. TV aerials are all horizontally aligned as TV signals are polarized by the orientation of rods on broadcast towers. Strongest signal is obtained when the rods on the towers and aerials on the house